Okay, now it's finding the vertex given the standard form. Alright, so before, the previous example, we have the vertex form of the formula and we went to standard form. Well, what if I have the standard form, which is the more common form? Standard form is the one you typically see in most applications. How do I determine the vertex if I have the standard form? Well, besides using the graph, you can use the graph, but we also want to be able to do it by hand. You should be able to do it by hand. Alright, so the vertex equation, there's a equation that we can use based on my A, B values that allows me to find my vertex. Alright, so remember the standard form is my A goes with my square term, my B goes with my middle term, and my C goes with the constant. My A term can't be negative, and so to find the vertex, as it turns out, the x value in the vertex is the opposite of B divided by 2A. And then to find the y value, well, you plug whatever that number is into my function to find my y value, right? That's what this means. I'm taking my x value I determined here and plug it into my function to find my y value, and that's the vertex. Alright, so that's what we're going to be practicing in these next couple of examples. And then determine if they're max and min, because that's important. The y value is the function value. So again, when we get to applications, I want to know the maximum height. Well, that would be the y value. The maximum height would be the y value that comes out of my function, or the minimum cost. That would be the y value that comes out of my function. And so the function value is the max and min. X is just the location of it. Right? X is where it gets me to my max and min. So we want to find the vertex, which is important for graphing, determining when the function's increasing, and using it to find my maximum or minimum, right, depending on which graph I have. Okay, so we're given the standard form of the line. So first thing is recognize that the A value is 3, the B value is 12, right? Because that's what I need to find my vertex. The x value in the vertex is the opposite of B over twice A. And so the opposite of B would be negative 12 over 2 times A, which would be 2 times 3. And then you simplify that. You get negative 12 over 6, which comes out negative 2. So the x value in the vertex is negative 2. The y value is the function value. So to find the y value, I take that 2 and plug it into my original function. That negative 2 goes into this expression to find my y value. So it's going to be 3 times negative 2 squared plus 12 times negative 2 plus 7. Alright, and then you simplify that. When you multiply that out, it comes out negative 5. Alright, and so the vertex would be the point negative 2, negative 5. It opens up because A is positive, and so it would be a shape like this. That would be where the vertex would be, and so that would make this a minimum, right? The minimum value is the function value. Whatever the function represents, cost, profit, whatever. And so the minimum value is the negative 5. Right? Negative 5 is the smallest function value. That would be the smallest function. Negative 2 is just when it hits that value. Right? So negative 2 would be, it gets me to my minimum, but the minimum is the function value. The minimum is the y value. So negative 5 is my minimum. On the side of those values is where it's increasing. And so remember, my axis of symmetry would be at x equals negative 2, right? It goes through the x value. And so to determine increasing and decreasing, I use the x value of my vertex, all right? So my minimum value is the y value. It increased increased on this side of that x value. So from negative 2 to infinity, it's increasing. It decreased, decreases on this side, right? Decrease, come down. So from negative infinity up to again, you don't include the negative 2, that's the word switching directions, right? So that's neither increasing nor decreasing at that moment. Right? And there's where it increased, decreased, all based on my vertex. Now, the second example. Alright, so again, I've got my function negative 2x squared, so we want to find the vertex. So remember, we want to find the vertex. So first I've got to write down my a, which was negative 2, my b, which is negative 5. The vertex is the opposite of b over 2a. And so in this example, it would be the opposite of b. I'm going to write it negative, negative, just so you can see it. But if you just want to write down the opposite of negative 5 as positive 5, that's fine. Over 2 times negative a. Negative a, or 2 times a, not negative a, 2 times a, which would be 2 times negative 2. Alright, so up top, the negatives cancel out, leave me with 5. In the bottom, I get negative 2 times 2, so I'm left with negative 4. And so my x value in my vertex is 5, negative 4. Alright, to find the y value, I take that 5, negative 4, and I plug it into my function. So I'm going to take negative 2 times negative 5 fourths squared minus 5 times negative 5 fourths plus 3, and so the y value comes out once I simplify that. Leave it in fraction form since I original, so I'm going to hit my fraction key because it comes out an ugly decimal. So it is the fraction 49 over 8. Alright, that's the vertex y value. Alright, so my vertex is the point negative 5 fourths, 49 over 8. A is a negative, and so it opens down, right? It's opening downward. That's its vertex point, so the axis of symmetry would go through the negative 5 fourths. Right. It would have a maximum, well, the maximum is the y value. Alright, so this is a maximum case. The maximum function value of this function is that ugly fraction, is the y value 49 over 8. That's the biggest value the function hits. So the maximum function value is 49 eighths. Alright, now increasing and decreasing. Increase. Now that's why I think it's helpful to have the axis of symmetry at that negative 5 fifths is where it switches. So on one side it's increasing, on one side it's decreasing of my axis of symmetry. And so it increases on this side, moving up to, so from negative infinity to negative 5 fourths is where it's increasing. It decreased on the other side, right? Decreased over here from negative 5 fourths to infinity. Again, you don't include the 5 fourths, that's where it's switching directions. Okay, so where it's increasing, decreasing are on each side of my vertex point using the x value. The maximum, though, is the y value. What is the maximum value of my function? Well, my function hits the biggest value at the vertex, and that biggest value is the y value 49 over 8. Alright, so that's determining the vertex. Alright, so we will stop there.